All right, two key terms right here, integer and rational number. If you remember what these are, good for you. An integer is just simply all whole numbers and their opposites. So an integer could be 6 or it could be -6 since that's its opposite. It could be 0 because 0 is technically considered a whole number. 0 is its own opposite. It could be 124. These are all examples of integers. Rational number is a number that can be written as an integer over an integer. So for instance, a number like 6 over 8 is a rational number because 6 is an integer and 8 is an integer, and 8 over 6 is rational because, again, these are both integers. You could make it a very big number like 1,207 over 72 because they're both integers. You could make 72 negative. It would still be considered rational. And likewise, because rational numbers are fractions, and fractions can be made into decimals, a number like 123 thousandths would also be considered a rational number. Even a number that was longer, like this one right here, this would be called 12,375 hundred thousandths. That would be considered rational because it does end right here, and you could make this into a fraction. You'd make it 12375 in the numerator and 100,000 in the denominator. So what's an integer and what's a rational number? You should know it. All right, hopefully you know what an integer is all whole numbers and their opposites. And then rational number is just simply an integer over an integer. And I left out this last part, but the bottom number can't be 0 because then it would be undefined. If you type that in the calculator, like 6 divided by 0, that's considered to be undefined. You can't divide something by 0. So now if you're asked to convert rational numbers, fractions, integer over here to a decimal, what you want to think about is that this bar right here really means division. So you're doing 5 chopped into 8 pieces. This should be less than 1 because fractions by their nature are less than 1, and this is considered a proper fraction where the numerator is smaller than the denominator. So 5/8, if we're going to make this into a fraction, you want to make it either, and students mix this up all the time, so I'm going to do it both ways. Either 8 goes here and 5 goes here, or 5 goes here and 8 goes here. Like I said, you want it to be less than 1. And if you notice, 8 goes into 5 0 times. That's what you want. You don't want 5 to go into 8 because this fraction is less than 1. The other way that you might have been taught this is that you could just extend this bar right here, and there's your division problem, 8 into 5. So 8 into 5, we can cross this one right here out. Goes in 0 times, goes into 50 6 times, and then you just do the standard algorithm for division from there. And we get 625 thousandths. Sometimes you might have a mixed number. It's the same process. What I like to do is I know right away that it's going to be 4 and something, and then it's just a matter of getting 9/40. So again, if you want to make this your division problem, here's 9, it goes right there. How many times is 40 going to 9? And so you get 225 thousandths. That's how you'd say that number. The third place value is thousandths. If you notice that both of these were actually what we call terminating decimals. Terminating decimals will always be rational numbers. And so, by the way, will be repeating decimals. Those will also be rational numbers. The only thing that isn't really rational numbers are numbers like pi, where there's no pattern to the decimal. It just goes on, and you can't really predict what the next number, the next digit will be in the sequence. Square root of 3, for instance, is another one. If you can convert fractions to decimals and you can convert decimals to fractions, here's 125 thousandths. We're asked to convert that, to a fraction. So when you do these, the key thing to remember is your place values. I'm dragging out my place value chart here. You should have these memorized. So just here's your decimal. The one thing that gets skipped, here's the ones place to the left of the decimal, is the tenths place. So here's tens, here's tenths. By the way, your code Mr. Fitz wears ties. That's going to be an answer to a question. Mr. Fitz wears ties. Code. Anyway, here's your decimal. There's the ones place, the tens place, the tenths place, the hundreds, the hundredths, and you can see the pattern. So the tenths place is always to the right of the decimal, then hundredths, then thousands. So if you look at 125 right here, since it's the third digit after the decimal, you pronounce that as thousands. So if I'm writing this as a decimal, it would just simply be 125 over 1,000. And you could simplify this since both numbers are divisible by 5. You could divide it by 5 to make it 25 over 200. And again, both of these numbers are divisible by 5, so you could divide 25 by 5, make it 5. 200 divided by 5, well, 20 divided by 5 is 40. Or 20 divided by 5 is 4, but making the extra 0 there is 40. And then finally, you could divide these again by 5, and that would be 1/8. That's what this is as a fraction. Again, knowing your place values really helps. The second digit after the place value, hopefully you have that memorized. But if I go over 2 places, that's the hundredths place. And so this would be 42 hundredths. So I would just say, if this was a fraction, a big old 3. And here's your 42 hundredths. And you can simplify that. Again, the numerator is an even number. The denominator is an even number. So we can say that this is 3 and 21 over 50. And that's as far as you can simplify it, even though 21 is considered a composite number, 3 times 7. 3 and 7 won't go into 50. So that's pretty much all there is to it.